Next, let's switch back to blue and factor a few trinomials. So I'm going to find the factors, in this case, of AC, which is 1 times 25, right? We label our A, B, C's, that add up to B, which is 10. So what are some factors of 25 that add up to 10? Well, that's 5 times 5 and 5 plus 5. And remember, I have a shortcut. When I have a leading coefficient of 1, I don't have to factor by grouping. I can automatically write this as x plus 5 times x plus 5, or rewrite that as x plus 5 squared. Problem 3, AC in this case is 1 times negative 6, which is negative 6. B is negative 5. What are some factors of negative 6 that add up to negative 5? How about negative 6 times 1 and negative 6 plus 1? Again, our leading term is 1. So we can use our little shortcut. I've got y minus 6 times y plus 1. For problem 2, I've got 49x squared minus 42x plus 9. My A is 49, B is negative 42, C is 9. So I've got 441 as my AC. My B is a negative 42. Well, 441 factors into 21 times 21. So it could be negative 21 plus negative 21, or 21 times 21. So I've got 49x squared minus 21x minus 21x plus 9, and then I can factor by grouping. The greatest common factor of 49x squared and 21x is a 7x. The greatest common factor of negative 21x and 9 is a negative 3, when we don't like negative leading coefficients. And remember that these should look the same. So I've got 7x minus 3 times 7x minus 3, which is 7x minus 3 squared. For our last example, I've got 2 times a negative 6. So my A is 2, B is negative 1, C is negative 6. AC is negative 12, B is negative 1. What are some factors of negative 12 that add to negative 1? How about negative 4 times 3? Again, if you didn't see that right away, you could always still make a table like we used to. We should be pretty confident in our factoring abilities by now. So I'm going to rewrite this as, let's use another color so you can see that clearly. 2x squared minus 4x plus 3x minus 6. Then we factor by grouping. Again, we can't use our shortcut because our leading coefficient A doesn't equal 1. 2x times x minus 2 plus 3 times x minus 2. These are the same, so I did this correctly. Collect my greatest common factors. Final answer is 2x plus 3 times x minus 2. Okay, for our last 3 examples in section 5.4, we've got 2 examples where we're going to have to factor by grouping, which I love. We've got one last trinomial that I haven't worked out in advance, so let's see what we do here. So I've got 28x squared plus 6x minus 10. Well, the first thing I want to do is pull out the greatest common factor here, which is going to be 2. That's the greatest common factor that 6 and 10 and 28 have. So I have 14x squared plus 3x minus 5. Okay, now I need to find the factors of AC that add up to B. My AC in this case is 14 times negative 5, which is negative 70. My B in this case is 3. So what are some factors of negative 70 that add up to negative 3? How about negative 10 times 7? Nope, add up to positive 3. So that's going to be positive 10 and a negative 7 because they add up to a positive 3. So now I have 2 times 14x squared, and I use these two terms to pull apart my middle term. I'm going to write it as minus 7x plus 10x because the order doesn't matter. And then I factor by grouping. I've got 2 on the outside because that was my greatest common factor. The greatest common factor, 2 times 14x squared minus 7x, that's going to be a 2x. times 7x. Note this could be a 7x. Oh, and now we're changing colors. I see how this is. I get what we're doing today, iPad. Okay, starting over. What's the greatest common factor of 14x squared and 7x? That's 7x. That leaves me with 7x times 2x minus 1. What's the greatest common factor of 10x and 5? That's 5. That leaves me with a 2x minus 1. See, these parts are the same, so I know I did this correctly. So I've got 2 times their greatest common factors, 7x plus 5 times 2x minus 1. So this is the fully factored form of our first example. All right, now let's factor by grouping. I'm going to put in my grouping symbols. The greatest common factor of xy squared and y cubed is y squared. So I've got y squared times x minus y. The greatest common factor of x cubed and x squared is an x squared. So I'm left with x squared times x minus y. This is the same. So I've got y squared plus x squared times x minus y. I see if I can factor this any further, and I can't because it's the sum of squares. For example 3, I factor by grouping. The greatest common factor of 20x squared and 4x squared is 4x squared. Got 4x squared times 5x plus 1. The greatest common factor of a negative 45x and a negative 9 is negative 9. We don't like negative leading coefficients. I've got 4x squared minus 9 times 5x plus 1. This is the difference of two squares, right? My a is 2x, my b is 3, so this is going to factor to 2x plus 3 times 2x minus 3, and I still have my 5x plus 1.